My name is BP. I'm the Senior Product Manager for Amazon Redshift. So this session is about, I know that you all are attending a HTAP summit, but hey, you might wonder, hey, what is BP doing here talking about Redshift? This session is talking about, how you can modernize your, architecture with both HTAP and Redshift. So make sure that you understand the session if you're in the right room. But anyway, I have Rahul today with me, so he'll be, showing a little demo as well. Yeah. So for today's agenda, right? So, in order for me to actually talk about, hey, the use case and architecture combining HTAP and also Redshift. So I'm going to start with talking a bit about, Amazon Redshift. I'm not sure that you're a user of Redshift. How many of you actually know what Redshift is and use Redshift? Wow. Yeah, good. At least we have people that know Redshift. So I'm just going to tell you what Redshift is and talk about HTAP and show you how these two works better together story. So talk about use case and architecture. Then Rahul is going to do a demo showing about one of the example architecture. So this is not about talk only, right, but show you how this can be implemented. So let's start with Amazon Redshift, right? So what Redshift is basically a cloud data warehouse. There are actually three pillars when we design Redshift as a cloud data warehouse. This is very important, and this will tie into the later in the use case and architecture section why this is important. So when we design Redshift, right, so the three key pillars is like analyze all your data, because right now today, hey, you might have data sitting in different data store, right? Transaction data store, data lake, and data warehouse, right? Even though, let's say you're using Redshift, we want the user able to use a single solution to actually create that data, regardless of what the data, where the data is, data warehouse, data lake, or transaction store. Then the other thing is that we want users don't have to worry about underlying infrastructure or heavy lifting, managing all those things, right? That's why the second pillar is very important. Hey, something like simple, easy to use. And of course, all this doesn't have to be very costly, right? That's why the third pillar, price performance. So we don't want customer to pay heavy price just to get the feature that they want, right? So that's why this is very important. So putting all that together, right? So I guess to today's context, right? So very important in terms of the analyze your data. I mentioned about we allow the user to create the data regardless what they see, right? So for instance, so on the left hand side, right, you see operational data store, right? So Redshift actually allow the user to create the data in place using a feature called federated query or materialize view, from Amazon Redshift itself. And the other thing is, hey, you have a data sitting in Redshift. So what do you do with the data? So it's very important that one feature is called data sharing. I'm not sure you heard of that. It's like it allows the user to actually share the data that's sitting in Redshift to other Redshift customer, whether it's the same account, different account, same region, or different region. So that's important. I'll deep dive more on data sharing and how it's tied to today topic discussion. The other thing is about ML. So the question a lot of customers ask, hey, we have data, we spend a lot of energy build analytical system, build data lake. So what's the purpose of doing that? So at the end of the day, they can run analytic, gain insight. But what they want to achieve is actually to have some sort of like predictive, analytic. That's where machine learning come into place, right? They want something that automatically can take action based on what data that they have. That's why Redshift have a features called Redshift ML. They can integrate into SageMaker, which is a machine learning services in AWS, to actually help user to actually build, train machine learning model and do real-time inference. And the demo will actually show you how easy to do that. You don't have to be a data scientist with PhD to actually do that. And yeah, let's look at data sharing, right? I mentioned about data sharing as a feature in Redshift that allows the Redshift user to actually share the data in Redshift to other Redshift user. How this perform is like, because Redshift is separation of compute and storage, so the data is stored in the storage layer. So that's why once you set up data sharing, it allowed other user in other account or region to actually access the storage in that particular producer account. So that's how data sharing works. And again, in the demo itself, Rahul is going to show you, hey, how easy is that? With a couple of clicks, you can actually set up data sharing. And the other thing is about third-party data set. in AWS, we have something called AWS Data Exchange. So this is basically a data marketplace. So when you heard about marketplace, it's just similar to like, hey, you know, if you're using iPhone, Apple, there's a marketplace there you can download software and stuff. But in AWS Data Exchange is a marketplace where you can go there to find a third-party data set, subscribe to that without ETL, you can actually use the data set itself. So that's a subscriber perspective. And you can actually be a data producer. What that means is, hey, you perform analytics, you build a data set, do some transformation. Those data sets might be very useful for other customer or user, right? So you can be a data producer, publish that into ADX, and actually monetize that and sell that if you want. So so that's about third-party data. So the next one I'm going to talk about is Redshift serverless, right? If you remember earlier, I talked about the second pillar of Redshift design is easy, something easy to use, right? That's what serverless come into picture. So the idea is like we allow user to just focus on writing query, gain insight rather than worry about anything. AWS will manage all of the provisioning of the cluster, scaling, and all those aspects. So this is fit into second pillar of ease of use for Redshift. So the last one pillar is talking about price, right? You don't have to pay high price to get the feature that you want. So Redshift is in fact the most cost-effective cloud data warehouse compared to other vendor. It can give up to 3x price performance. The reason for that is we have a lot of performance feature. I'm not sure you can see down there. So we have automatic workload management, for instance, concurrency scaling, which can automatically scale up to support virtually unlimited number of users. So those are the features that we built into Redshift for free that help you to achieve the performance that you want. So now let's back to this summit, right? HTAP, I'm sure that you are a heavy user of HTAP. You know better than me about HTAP, right? But back to the HTAP definition. So come back to the books like definition from Gartner is talking about HTAP is support both transaction processing and analytic processing. So keep that in mind. Then the question is, hey, since HTAP basically able to do analytic, why do we even need Redshift, right? That's a key question, very important to understand. Before I talk about that, let's look at understand how HTAP evolved, right? First thing first, right? Back in the old days, so we have like normal we have relational engines that hey user run transaction on that. So that's why you see that we have a writer node that support the transaction. Then people want to start running reporting and all those stuff. So that's why they create a reader. But the problem for that is work fine, but they might start running issue, especially on the performance side, right? When we talk about performance at scale, it will become slow. And also management, you have to manage 2 nodes instead of like 1 node, right? So that's why they have other solution coming out. Basically, they put everything into in memory. There's solution like in memory DB, it will fine, give you the performance that you want. But the thing is like, hey, what happened to the cost? Everything come with the price, right? Memory is not, cheap, but even right now. So if we talk about data at scale, right? Terabyte, petabyte kind of scale. So cost might be an issue. So that's why we have these modern HTAP solutions. Instead of like using memory, they have 2 different storage layers. You have a row store, they're doing replication into a column store. So when you run transactions, it's actually accessing the row store. When you run analytics, it access the column store. So let's dive into what we have today, talk about Redshift and HTAP, how this can work together, right? The first thing, right, ask yourself or your customer, right? It's very common that in customer environment, right, they not only run one single database, right? Like, in HTAP, right, one single database, right, they can support, both, transaction and analytic. But in the situation that if they run multiple, HTAP databases, what happens if they want to run analytic cross different instances, right? So that's why I call this cross databases or cluster analytic, right? So that's where they actually need to consolidate the data into a single instance to able to run analytic across that, right? So this is where Redshift could fit in the picture, right? So might look complicated, but the fact is, when you talk about consolidation of the data, right, you still need to build, some sort of like ETL or ELT pipeline to actually load the data from those HTAP sources into Redshift. Then your analytic application can actually point to Redshift to run analytic on the data cross, cluster on databases. So the next thing is like, hey, earlier I mentioned about, machine learning, right? That's very important. So that's most of the customer, that's the end goal, right? Hey, why do you spend all this effort building your infrastructure for data analytics? So the purpose is not only running, reporting, right? Reporting is give you an insight, but at the end of the day, we want to have a capability to able to build, a machine learning model and run ideally real-time inference, right? You want to do a real-time prediction of what's going on to your business so that you can, take, immediate action, right? So that's why the second use case is about machine learning. So a lot of, HTAP, solutions, so they are great in supporting both TP and AP, right? But when it comes to the machine learning, model, this is where Redshift can be a complement, right? Especially when you talk about you want to have consolidated data from different, transaction system, and you can leverage the ML capability in Redshift to run, build and train machine learning model on those data. So you'll see how easy to run this, create a machine learning model in Redshift. And the other thing is about, okay, now you have the data, you have the machine learning model, you can do a prediction. Let's say you have a use case to predict your business outcome, right? Let's say how many customer are going to churn, that's a very common use case, right? Or, how many, in the marketing sense, how many customer is going to, use term deposit or something. A lot of use case that, might be useful to other customer as well. So that's why if there's a scenario that, hey, those business insight and critical to any downstream customer or partner, so that's where you can actually leverage Redshift data sharing, okay, to share it to other customer, okay, whether they are on Redshift or they can even publish the data set to, AWS Data Exchange. So the other use case I'm talking about, I call it aggregated transaction analytics. So this sounds a bit confused to me as well, what actually that means, right? Row store, like from, for instance, from, any HTAP solutions, right? It shines when you do a single row query, right? But in Redshift, like, those column sort, if you do a single row retrieval, the performance might not be great, right? But the thing is, when you do an aggregation of the data, consolidate data from multiple HTAP system into Redshift, and there are use cases that customer really, what they need is not to pull everything from Redshift, right? Just pull a single row. But in this case, if let's say they have a millisecond requirement latency on the single row retrieval, that might be an issue for Redshift to provide that. So that's where this use case coming into picture. So they do an aggregation on the data, from HTAP into Redshift. Then they pull the data out into HTAP again, where HTAP will be strong in providing the single row retrieval of those aggregated data to the downstream consumer. Okay, so that is the situation if let's say the downstream consumer need those of like second or millisecond latency or single row retrieval. So that's another use case. So the next one is like, hey, I'm not sure you can clearly see. So this is very common right now. So how about this of data? Right? Today we are talking about, a lot variety of different data source, IoT, log, streaming, all those of data, right? What do you do with this data? Can you store this data in HTAP system? Can you run transaction on this data? Can you run analytic of this data? How do you deal with this data? So because, in a very true customer scenario, we are not only deal with transactions data, right? More and more data is coming from this sort of like unstructured data or, streaming data. So that's why, we have Redshift in the center, and we have a transaction data that, you can load or stream into Redshift to run analytic on transaction data. Then this is very common streaming data, right? So, we have like from AWS, we have Amazon Kinesis data stream or, Amazon managed streaming for, Kafka. So those are the services that AWS has to actually stream data from different sources into AWS. So from that sources, right, Redshift have a feature called streaming ingestion. So what that means is it integrate with those two sources. We will continuously stream the data into Redshift. So right now you have a transaction data load into Redshift. Then you have the streaming data stream into Redshift. So you can run analytics on the streaming data plus the transaction data. Then we're talking about semi-structured data as well. So what happened to the semi-structured data? So for instance, JSON. So it's very common, like customer load the data into a data lake, right? So because that's a best fit to load that sort of data rather than load into a relational engine. So in Redshift, right, we have a feature called Spectrum. So what Spectrum feature is allow the user of Redshift to run SQL statement to create the data sitting in the data lake, whether it's in structured data or unstructured data. So right now you have 3 different data sources that you can query from Redshift itself. Remember, the first design principle for Redshift is analyze all the data, right? Regardless where the data is sitting, transaction system, streaming, data lake, Redshift allow you to query the data. So what important is you can run analytics across all different data sources. Then you can run ML on those data, and you can share the data to the downstream consumer. Does that make sense? So this is a very key use case, how you can leverage different features in Redshift and combine the key feature of HTAP solutions. All right? And yeah, so we are going to do a quick demo about combining a couple of very important use cases, right? This is not about just talk, hey, I can talk for 1,000 hours, how good is Redshift, how good is HTAP, right? Doesn't make sense if I'm not able to implement that. That's what I'm going to, Rahul is going to show you. So you want to talk about the architecture?
Yeah. Yeah, I can talk about the architecture, but any questions so far?
Any question before we move on with the demo?
So we have an HTAP database. We have simulated some data in a MySQL database, and that could be considered as HTAP for this demo. And we are going to move that data using a database migration service into Amazon Redshift. And then there is a machine learning model. So when you create machine learning models, if you are a data scientist who's really good at identifying the right models and which models need to be applied on your data, you can create the model with those hyperparameters. And the good part is when you create a model in Redshift, the model training is happening on the SageMaker. You only pay for the training part of it, but once the model is trained and ready, it's deployed on the cluster. So any predictions or inference that are made on that data set, there's no additional cost to it. So I'm going to show that in the demo right now. So on my AWS console, I have an RDS MySQL database, which is like a source. Let me zoom in a bit. Okay. And then I have 2 Redshift clusters. One is going to be a producer. So there is a producer cluster, and then there is a consumer cluster. So the idea is we'll move some data from this RDS database into the producer cluster, run some inference on it, and then share that with a downstream cluster, which is a consumer. And all that will be done in like near real time. So over here, I'm logged into my MySQL database. And before I insert some data into this, let me go through the DMS components as well. So in database migration service, you simply start by creating endpoints. So you have a source endpoint and a target endpoint. In this case, the source endpoint is MySQL, and the target is the Redshift producer cluster.
Yeah, sorry. Before we move on, and you're familiar with what DMS, database migration services, is? maybe you want to give like 10-second intro about that.
Yeah,
What
so
is it?
with database migration service, especially with MySQL, for example, you can apply a full load of data and then you can also apply incremental load. So DMS would take care of processing any incremental data changes and applying them to the target. And different sources and targets are available or supported by DMS. So you can create endpoints to things like Oracle, MySQL, Aurora. It could also be other unstructured sources like DynamoDB. And then you can write the data into some targets like Redshift. You can write it back into S3, or even like streaming sources like Kafka or Kinesis.
So basically, it's a replication tool, allow you to replicate, from a source into a destination. It's just an example, right? So if we are using any replication tool, ISV application tool like Fivetran, Matillion, so those can work as well. For the purpose of demo, we will just use this to show how you can replicate the changes.
And the speed of replication or the replication performance depends on the replication instance. That's just one of the factors. There are other things like you can always tweak the task settings to make the processing faster.
So is DMS like a one-time operation, or can it continuously be replicated?
Yeah, it can also be like it does have a change data capture feature on it, so it can also do ongoing replication. And I'll show that shortly on my DMS task window. So I'm going to insert one record in MySQL, and I'm also going to delete one. So let's go ahead and do that. And when I go over to my DMS task, this is my database migration task, which is, as you can see, it says load complete and replication ongoing, so it's going to take care of the changes as well. And over here under the table statistics, you can see how many inserts, deletes, or updates were applied. This is showing data for past few hours, so these numbers can be a little different. But you can look at all the inserts, deletes, or updates that were applied in the recent past. And if I go back to so this data was written to my Redshift producer. With Redshift, you get a query editor on the web interface itself, so you don't have to configure things like data grep. I mean, I have used data grep, but I find query editor to be more convenient, so I don't need to work with other SQL clients like SQL Workbench or something. So I inserted one record and deleted one, and I can see that like the one with 52 is missing. And then, so far we have got the data into the producer cluster. And I had already created the model for this demo because model creation can take some time. So this took about 40 minutes to create the model. And it was simply a create model statement. And this is without any settings, like without any hyperparameters. I have left it for Redshift to choose the right model based on my data. And all that I'm saying is I want to predict something. So I've said that I just want a new value under this variable y. So that's my target.
By the way, so the use case for this is like, a bank marketing, right? They're trying to see, hey, whether their customer will actually, use their term deposit, right? They try to predict based on the past, behavior. So that's what the data about, and what the, machine learning model. That's what they try to predict.
So as you can see here, I've used all of these columns and I've passed them on to the create model statement. And I'm asking Redshift to come up with the right model in order to predict the user behavior depending on this data. So with the new, once the model is deployed, you can check the model on your cluster using the show model statement. And it will have a model state of ready, which means you're ready to use the model. And it will also tell you which model type was chosen. So this one is it identified the problem type as binary classification, and the model type is going to be XGBoost. And the key thing to remember is this model has been deployed on the cluster. So none of the prediction is actually going to happen outside the cluster. So I'm going to quickly run some prediction based on this data set, and I can identify how many customers based on this data set are going to opt for a term deposit. So the next part is if I want to share this data downstream with other Redshift clusters or users, I would basically create a materialized view out of this data set and then share that with the downstream users.
So basically what happened is we have a machine learning model, we have a predict functions that you can input a data set, then it can do a prediction whether the customer will subscribe to a term deposit or not. So we're creating a materialized view that contains the prediction, and so that we can share that to a downstream consumer that need that prediction data.
So when it comes to data sharing, there are two options. You can create a data share which is sharing it with other Redshift clusters, and since the storage is separate from the compute, other Redshift clusters just bring their own compute and they can read from that same storage. The other option is data exchange, which BP covered, and this is to monetize on your data. If you want to push this data out on the marketplace from where people can subscribe this data set, that is also an option when it's available on the console. So I'm going to create this data share called HTAP, and it's simply going to ask you on the user interface. You can choose which objects you want to share downstream. So you have full control or the authority over what data sets you are going to share downstream. At any point, you can add or revoke objects or permissions. So this is going to give me the list of schemas and all the object types. It is just refreshing the metadata right now. So we'll give it a second. And one key thing to remember is data sharing is real time. So there's really not going to be a lot of latency when you try to query it from consumer clusters.
Yeah, and also the data is not copied, right? So the purpose of data sharing is, hey, you have a single source of truth in a producer cluster, and it will be persist in the producer, storage. When you share it, then consumer can consume it. So there's no data movement and all those things. So the consumer can query the data from the producer in real time.
So I'm going to choose tables and views and add specific objects, and I have created this view right now. I'm just going to add this view and share it with our consumer cluster. So this is I'm just going to select the consumer cluster from this drop down and create data share, and then that completes like most of the process. We just need to go to the consumer and create a database out of this data share in order to start querying it. So when I go to my consumer cluster, it's going to show all the data shares that are available for this cluster. So I can see that HTAP data share is available over here. I can create a database out of it. And then I should be able to see that database under the databases tab. And you can also go back and query it using the query editor. So I'm going to connect to the consumer. And I can see the HTAP producer database here. So and I can then start querying the data that has been produced by the producer cluster.
And consumer does that have to be a Redshift?
Yes, in this case it's a Redshift data sharing feature which is making it seamless. So it has to be Redshift.
Will it be EMR or something else?
Not right now. that is the demo. Any questions?
Questions, feedbacks, thoughts on this? Is that make sense, or the use case?
And BP is a data sharing PM, so ask.
Thank you very much.
Thank you.